know that if there are any plans to have a Cassini-class orbiter for Jupiter.
I know that they've talked about it. The decadal survey folks don't at the present time have any mission like that in the current, the next decadal from I think it's 2012 through 2022, that time frame. There may be something after that, but 10 years is a long time, and I don't see anything on the drawing boards given the current economic and financial funding level that NASA is being given. In fact, we've seen 20 to 30% of the planetary science budget lopped off with the current fiscal budget. So that's a real problem. We've obviously withdrawn now from the Mars and the European consortium that's planning the 2016, 2018 missions to Mars, and the Russians obviously have stepped in and will be providing Proton launchers for that particular program. So I don't see anything at the Cassini level coming out of the NASA exploration program for a while.
What do you feel would be the most important target that we should be heading to next after the couple of plans as far as planetary exploration is concerned?
I think some of the moons of Jupiter are prime candidates for missions, and in fact, NASA does have in the decadal survey, I think, a mission to one of the moons of Jupiter.
Europa.
Yeah, Europa. And I think probably the current Dawn mission on Vesta, and they're wrapping that one up at the present time. They've been there almost a year now. They arrived late in July, first part of August last year. That's been extremely successful for a relatively small spacecraft. And then obviously they're going on to Ceres and will arrive in, I think it's February of 2015 for a year's exploration of Ceres, which again is a dwarf planet. The discoveries at Vesta indicate that it's a planetary fragment left over, that it's got some partial melting, it's got a core. It's probably the type of thing that crashed into the Earth during the Earth's formation any number of times. Of course, the moon and the formation of the Earth and the moon system was a Mars-sized object, but the protoplanetary objects the size of Vesta seem to have been very typical in the very early development of the rocky planets.
With that in mind, do you think that gives any sort of validity to the theory that Earth formed in where the asteroid belt is now?
I don't know that that's the case. I've seen some recent research articles indicating that Jupiter formed much closer and then migrated outward, contributing to the rocky planet formations. That's something that is still very much up in the air. The whole notion of how did the solar system form and where did the planets form is a subject of intense research at the moment. There's been some very recent publications on that, and no one's really got a good handle on it yet. Lots of interesting computer models, and you can see how planets move in and out and kick out, forming objects and stuff. One of the papers that I read recently indicated that if you have 4 gas giant planets form, such as 2 Jupiter-Saturn objects and 2 Neptune-Uranus-sized objects, that configuration is unstable. In fact, if you have 5 objects of that size, one of them will eventually get ejected, and that leads to a stable 4-object, 4-gas giant planetary system with space left over in the interior for the rocky planets. So the computer simulations that the scientists have recently done in that area are very, very interesting. And we'll see what develops.
At the same time, have you seen some of the studies and theories about how that 5th gas giant might still be somewhat in our solar system in a highly elliptical orbit somewhere way out in the Kuiper Belt?
Yeah, it's not at all clear what happens to an object that gets expelled from a solar system. There are some indications from the Spitzer Space Observatory, the infrared observatory, which can see very just warm objects, not in the brown dwarf category, but although it will see those objects also, but some just warm planets. And there's some indication that Spitzer's caught some of these wandering planets expelled from some solar system someplace in the vicinity of our solar system. Now, whether it's an object that was in fact part of our solar system or comes from a solar system, tens of light years, thousands of light years, millions of light years away, unknown. We just don't know what those objects are and what their origins are.
Do you feel like New Horizons might be able to shed a little bit more light on the subject and hopefully give us more information and close that case?
No, I'm not sure that New Horizons going to provide any substantive information on the formation of the early solar system and where some of those wandering objects came from. Certainly it'll give us information on the Kuiper Belt and what the formation of that environment's been.
What do you feel is the most important thing that your everyday common person needs to know about space?
I think they need to know that space is the future of humanity. They also need to know that objects in space are a very, very long distance away. The moon, for example, is, with present technology, a week away. It's the closest object in the solar system. Mars is 8 months to 9 months away. That's a long distance. So, those are 2 things that the man on the street should know. The other thing I think that's important for them to know is that a vast amount of technology has come out of the space program and the aeronautical program over the last 70, 80 years. Much of the things that they take for granted, the computer chips in their automobiles, the cell phones that they use, the computers that they use, all have significant inputs from the space industry. And the other thing, finally, I think the last thing that they need to know is that the space program is a very, very tiny fraction of the federal budget. If you ask the typical man on the street, how much is NASA's budget, you get figures as high as 20% of the federal budget is being spent on the International Space Station and sending rockets and spacecraft to the planets. In fact, now with the current NASA budget, we're now down to something in the vicinity of 1/4 of 1% of the federal budget is devoted to the space program, and considering the implications of the technology and the contributions to our welfare and our education, we should make sure that the typical person understands what an incredible return 0.25% of the federal budget is giving us.
Well, is there anything else that you'd like to add?
No, I think we've covered an awful lot right now.
Well, thank you very much for joining us.
You're welcome. Thank you, Michael. Appreciate the time.